Good evening. Welcome to a video discussion from NYNJPA Weather, a special one. It's Saturday evening and the cold air is on the way. Now, the Arctic air is currently over portions of Canada. How do you know? Well, it's only 3 degrees in portions of Quebec, 12 degrees and 19 degrees in Ontario. And as we work south into western New York, we're in the lower 30s. And in our neck of the woods, in the Philadelphia and New York City metropolitan area, temperatures are rapidly falling from the lower to mid 40s along the coast and upper 30s over the interior. And we're starting to get some snow showers move into the Philadelphia and New York City metropolitan areas, especially over northeastern Pennsylvania and the Hudson River Valley, that will clip through the region. Now, you could tell there's an Arctic air mass on the way by the smell of the air. It's more of a crisp, polar type smell. You know exactly what I'm talking about. And also the sky has a nice little red hue to it as the scattered snow showers approach the region. Now we can see this very clearly on the latest observations here from SPC. See the snow showers approaching the region, our Arctic cold front moving through. These snow showers and squalls will be capable of producing a heavy burst of snow here and there. We can see that very nicely on the radar. These little squall lines of snow showers. So don't be surprised if you're caught in a quick little heavy burst of snow and then it's over as quickly as it comes, ranging anywhere from about 10 to 20 minutes before ending. Could be some slight accumulation, especially on grassy surfaces. This isn't a big deal, but it might catch you a bit unguarded as these snow showers move through. Of course, the main story is all about the storm for this coming Wednesday. This is the latest water vapor satellite picture. Now, I love using the water vapor satellite picture because you can clearly see all the players on the field. We have one upper level low and a very strong block over the northwestern Atlantic. Here's our Arctic front with our Arctic disturbance picking up moisture from the Great Lakes and producing snow showers over the region. And here is our subtropical jet stream and our very powerful disturbance. Now, I cannot underestimate the degree in which some of these models are under forecasting the strength of this disturbance. This disturbance, with its own cold air, is producing snow and ice threats for the southwest, the southern plains, and eventually portions of the mid-Mississippi River Valley. This is a very strong subtropical mid to upper level disturbance. It's a well-developed upper level low, and that disturbance is going to be tracking along the Gulf Coast and eventually will head towards the East Coast. That's not the question. The question here is, how does that disturbance interact with this polar disturbance well up here, over here in portions of Canada, entering the Yukon territories and the northwestern portion of British Columbia? As this disturbance dives south, the models are producing a variety of different solutions on how this disturbance will evolve. I currently don't really like any of the models right now. They're close, the European and Canadian that is, but they're not exactly what I'm envisioning on how this storm will develop based on the way that the pattern is currently set up. It's not too far off again, but I like it a little bit further east. So we're going to take a look at some of the models here, and I'm going to show you exactly why they're different and why they're showing different surface representations. First of all, we'll do the NAM. Now, really, you never want to use the NAM beyond 60 hours, and that's kind of pushing it. But I know some people are going to bring up the NAM at 66 hours and beyond. Look, this phase happens way too early on the NAM model guidance, and the reason why it does so is because the NAM at about 60 hours starts to lose the definition of this disturbance and starts to produce a kind of spread out, poorly organized, but yet strong positive vorticity advection that's lifting in the atmosphere. So you see how this polar disturbance is very strong and compact, but this disturbance is kind of spread out all over the place. Well, what happens is that the model assumes that there's going to be an earlier phase, and so the earlier the phase, the further north and west the storm track. So you end up with this type of storm track, which if you extend it out beyond 84 hours, would suggest a storm track towards northeastern Pennsylvania and up towards Lake Champlain. I don't think that's going to happen. I think this phase on this Malgans is happening too soon based on the wavelength of the entire 500 millibar pattern. If there was no blocking whatsoever in the northern Atlantic right now, I'd probably go with this type of solution. But given that there is some, I think this is happening way too fast here on the NAM Malgans. And then we got the GFS. Oh, the GFS. Well, what can you say? It basically suppresses this disturbance while really making this disturbance, the southern jet stream disturbance, way too weak. So as a result, I mean, look where it starts at. It starts with this powerful upper level low and just has it collapse as it's moving forward in time. And so therefore there's really no interaction whatsoever between the jet streams. In fact, the polar jet stream disturbance, even though it's strong, just doesn't dig, doesn't carve out a deeper trough. And so as a result, you end up with no interaction whatsoever with the polar and subtropical jet streams. And so you end up, despite this disturbance somehow going negative, with no storm whatsoever for the northern mid-Atlantic. This is an example of a disturbance that is way too far east. This solution is way too far east because there is no phasing. And again, I just don't buy this idea either. This would have to assume that the polar disturbance just has no influence whatsoever in this weather pattern, and the subtropical disturbance completely collapses before reaching the east coast. Not going to buy it. The Canadian, though, is pretty interesting. Now, it keeps the strength for the most part of our subtropical disturbance. It focuses it and keeps it as a strong upper level low with a positive tilt as we head into Tuesday morning. By Tuesday afternoon, it's a little bit more neutral and starts to feel the influence from our strong Arctic disturbance. Now, while that's happening, this whole phasing combination that starts to develop leads to a strong southerly wind up the coast that warms up the atmosphere. So even locations like in the Poconos ends up with a warm rain as the cold air is trapped up towards the Great Lakes, and our low pressure system starts to track up the east coast. As far as the actual idea behind this solution, I generally agree with it. I think there will be phasing. I think there will be a storm on Wednesday morning. I think it will move fast. And I think that the immediate coast is in for some very heavy rainfall. However, again, I think the phasing here is a little bit too fast. You push this 6 hours later, and this storm track is more off the east coast, and you have more of a snow threat over the interior. The point tonight is don't jump the gun, okay? Be prepared. If you're traveling this coming week, do yourself a favor and plan for some alternate routes, or at least leaving a little bit earlier. Better to be safe and get some turkey than be late and never having any Thanksgiving, which would really, really stink. So what I would say to you today is that the Mals, especially the European and the Canadian Malgans, are very close to having a correct solution here. I think they're on the right track. I think we're dealing with a storm here that pretty much everyone in the major cities along the coast can expect to have very heavy rainfall on Wednesday morning. This is a fast-moving low-pressure system. Don't be surprised on Wednesday night into Thursday morning. You have some lingering snow showers behind this departing low, even down towards the coast. And again, I think the interior, the question really comes down to when the phasing actually happens. If it happens, let's say 6 hours later, then this low pressure system is here rather than here. And if it's out here rather than here, then this whole pressure line, this whole thermodynamic setup right here is pushed off the coast, right along the New Jersey coast, and we end up with this cold air over portions of northeastern Pennsylvania and the interior, rather than shoved all the way back towards the Great Lakes. So again, there's no need to jump the gun yet because we have a couple days. I don't think we really should start to buy into any of the specifics here in terms of phasing, rain snow lines, or anything of that nature until we get to Monday when we have a really good idea and we start sampling the data with these two disturbances at a much better field. Okay? So, again, the idea here is to be prepared for a major storm on Wednesday. Wednesday night everything clears out, and Thanksgiving is cold and windy, temperatures struggling in the mid to upper 30s. I would not be surprised if no locations break 40 degrees on Thanksgiving nor on Black Friday. And we end up with rather windy conditions as well, especially during the Thanksgiving Day parade. That is going to be one chilly entrance for Santa Claus this year, with winds ranging anywhere from 20 to 25 miles per hour, gusting over 40 miles per hour. It's not going to be very pretty for Old St. Nick at the end of the Macy's Day Parade, that's for sure, with these strong winds and cold temperatures. So be prepared and bundle up on Thanksgiving. And again, for Wednesday, the good news is that the storm's going to move quickly. The bad news is that it's going to produce a lot of heavy rain, 1 to 2 inches of rain, and then exit out into the Atlantic. And of course, the interior, we'll keep an eye on it. Right now, it looks more wet than white, but a little bit of a shift of those disturbances. Again, I'm going to keep an eye right here. Wednesday morning, okay? Even a little bit earlier than that. Let's go Tuesday night, 84 hours out. Tuesday night. See how these two disturbances start to interact. If this looks like it's going to be delayed by 6 hours, like for example, this picture happens more like 6 hours later, more towards Wednesday morning, then this storm track here is going to be a little bit further off the coast. So a lot of things to keep an eye on, but it looks like we are going to have our storm the day before Thanksgiving. That's your forecast discussion for this evening. Of course, I'm your meteorologist, Stephen DiMartino. You can follow the latest weather information at nynjpaweather.com and nynjpaweather on Twitter, Facebook, Google+, and of course on LinkedIn. Have a wonderful night, and as always, stay safe out there.